So thank you, Mariana. And I have to admit, this is a real honor for me as well. Rick and I have worked together off and on for, 5 years now. And to be able to actually come up here and present with him is quite an honor for me, so I'll just tell you that. So I'm not going to introduce myself since Mariana did that for you. So some things we're going to talk about today, we're going to we did the introductions. We're going to talk about some of the business challenges at IP, and I think that are very prevalent. I've had some similar discussions this week with some of you, and I think these are across manufacturing, across the paper industry. We're going to focus on several business use cases, one around batch digester performance, center lining on a paper machine, sheet break rethread calculations. And we're going to sum it up, and I'm going to give you a couple of tips from the trenches on design. I have to admit, I've become much better at the design aspects of things. I have built things that look like a clown threw up on the page, and I'm going to try to steer you away from that. Don't do like I did. And I learned that from some great books. I'll give you a couple of things from those books, and then we'll close it up. So a little bit about International Paper. They're the world's largest pulp and paper company. You guys can pretty much read that slide, but they have almost 2 million PI tags to deal with. And as you guys know, it's tough to get context around those, turn them into English, turn them into actual information. So that's what Rick and I have been working on, trying to focus on some very specific problems. So I wanted to start with this slide to actually talk about the challenges, solutions, results. And the results are still to be determined a little bit, but I wanted you guys to see this right up front. This is what we're dealing with, and this is what we're trying to do. To me, one of the biggest challenges we have in the industry as a whole, not just pulp and paper, but pulp and paper is probably one of the worst about this, is we have an aging and retiring workforce, and then we have a big gap, and then we have a lot of people coming into this workforce, lots of them. I have one myself. He's 20 years my junior. So how do we bridge this gap in experience? And I think some of the things that we're trying to do will help bridge these gaps. So what we're trying to do is focus on some very specific problems and give some people some context as to what's going on. So some of the tools we're obviously using AF, we're using event frames, PyDB Enterprise, PyVision, PI Integrator for business analytics, and then we're getting into some of the BI tools like Power BI and Tableau. So we really think that the combination of those tools can really give people insight and context that they've never had. So with that, I'm going to turn it over to Rick for a few minutes, and I'll see you again in a minute.
So thanks. So I'm Rick Smith, and for those of you, if you've seen my videos, I've been talking for several years about this journey of how do we get from the old way we did things in PI to the more modern way. And part of it was because I'm getting kind of old. I'm retiring in a few years, and I'd like to play with some of these newer tools. So I had to convince the company that we needed these newer tools. So one of the ways that we did that is we went with, I worked with Jim a few years ago, and we said, we're not going to try to sell the company like we have in the past. We're going to go solve problems because money sells. And the first ones that we did, and I've talked about this in some of the past conferences, was around batch digester performance. So I know there's a few people in the room, so I'm going to get really technical here about what digesters do. They take wood chips, and they make oatmeal. Okay, we good? Okay, so I did some work to demonstrate to the companies that we needed to do this, and then Jim followed on with some work picking up where I had left off. So Jim had come into our mill looking with we have a runnability problem on the paper machine. So we collected a bunch of data, did some analysis, and it appeared that the digesters were really where the problem was coming from. Well, that's good because we've done a bunch of work in the digesters already. So maybe we can just reuse some of that information that we've done in the past, and we could go from there. So we let the data take us to the problem instead of coming in with a problem where we thought we knew the answer, and just let the data take us to where the problem was. So some sorry. So some of the multivariate analysis had picked up that the digesters were the problem. Now, as we were looking at it, you know, the digesting process is very complicated, but it turned out that we started seeing some inconsistencies over time around steam usage, so we wanted to delve into that because steam is one of the more costly parts of the process. So the first thing first, like you saw Mike talk about before with the brown stock washers, we want to do analytics. We need to get to summarize the data, so we got to put some context around the data. So we essentially built out our asset framework around the digesters. So this is some of the work that I had done originally. And that the second part of that is how do we do to visualize it. So if you were to look at some of my early displays around vision, it was just a bunch of trends and data, and it wasn't organized in a very natural fashion. So leveraging on some of the lessons that Jim has learned and shared with us, we needed to organize the data. So the steam is actually over on the right. That's what we're going to get to. But since we want to reduce the number of displays, we actually kind of use these displays for many different things. So as a human, you actually, in the United States, read from top to bottom, right to left. So you need to put the most important information upper right and top left. You'll also notice that we put boxes around this. Now this is something we actually learned from some of our engineers in the mills. You know, group things together because otherwise the person doesn't know where to look. So we have the summary of the digesters on the top, and then we have H factor where we're talking about the digester work. Then we're getting into the temperature profiles. That means something more for the operators and the engineers. And then we get over to the steam. What are the valves doing and what are the steam statuses doing? So when we did this original work, we collected across all the digesters 3 years of data, I think 80,000 event frames to analyze. So this is what it looks like in an Excel spreadsheet. That was the first set of tools that we used. But it'll allow us to do some simple ad hoc analysis to kind of say, are we moving in the right direction? We could do some simple filtering. It's something we could export out into Excel and give to people. Now, one of the things that I talked about in the past was the mills had spreadsheets to do this, but it took them 45 minutes or a couple of hours to actually download all the data and do all the manipulations. And after we put the context around it and the frames around it and let the event frames go summarize the data for us and pull out the summary data, they're able to go answer questions in 5 minutes instead of 45 minutes. So that's much better. The other thing that Jim did, and you see the little blue hyperlinks. So we're building up URLs that we can pass to vision. So if we filter this down and we start seeing data where this is of interest compared to something else, then we click on those links and it takes us to that event frame. And we can see it in vision. Well, Excel is a good place to do some ad hoc work, some cherry picking work, but really, if you go look at all the shows and all the presentations, it's about all these drag and drop BI tools, right? Now, I'll talk later about, in another presentation, about getting all that data to these BI tools and the nightmare that is. But it's very powerful that once you've summarized the data that you can then do it. So this is just some trends over long periods of time. We start summarizing the data so that we can compare the past to the present. Now, in the story that we told the mill, we said, hey, I don't know, this was Jim talking to us. I don't know much about your process, but it looks like your steam usage is going up compared to the past. And the process engineer said, yeah, we kind of know about that. We made a process change. And Jim said, okay. But when I go in and I look at it, you're different across your digesters. You have some really good performing digesters. And this was his clown chart he was talking about before. This used to be all multicolored, but now it's just green and red. Green being the good ones, red being the bad ones, to highlight the issue. So on the left side, we see that the green arrow, it was 25% good cooks. But over time, as you go down the display, you see that number is decreasing. So we're making fewer what we call good cooks. And then on the right, the red line is really big. Those are held cooks, and holding the cooks in a digester is a bad thing. It makes for worse quality. And that number is actually bad and getting worse over time. So very quickly, we could start saying, Are we having data across the digesters differences? Where do we need to go look? And then over time, it's actually changing in time. With pictures like this, we can tell a story with operations and start asking questions. And we can put on this hat of the data scientist and say, I don't understand your process. I understand data. Process person, can you describe what I'm seeing here? And maybe that tells you something. So once we leave the digesters, we start going over to the machines. And I'll turn it back over to Jim because this is more of his work along the machines.
Thanks, Rick. So yeah, that was really interesting, and one of the things that I started to pick up too was we could put multiple data sets together as well. I mean, one of those displays actually had weather data with event frame data on it, and we were looking at trends, and we could see some correlations there, and it drove some other questions, and which started me thinking about, well, how can we apply this on machines and other places? So, the business problem, and as I talked about earlier, lots of turnover in this one particular mill that we were working in. I mean, they had gone from people that had 25, 30 years of experience working on paper machines, and now all of their operators have 2 years or less experience. Big problem, right? So we got to help these folks. The old hands, they knew where to run the machine. Okay, now all of a sudden you have much less experienced operators, and their supervisors may have 5 years of experience. So big problem, and I know everybody has this. We're seeing this across all industries, and paper is, like I said, one of the worst. So how do we keep them out of the ditch? Okay, and a lot of from the engineering perspective is, how do we even calculate what our limits should be? How do we figure out what's good? So we were working on some tools that allows everyone to kind of get some more context and understand what their limits really ought to be. So for those of you that are in the room not from the pulp and paper industry, I'm going to way oversimplify what machine learning centerlining is, but this kind of gives you the gist of it. So really what we're trying to do is figure out what are the optimum parameters to be able to run the machine and have good runnability on the machine. And figure that out for every grade run. And we want to find out the key ones, not 1,000 of them, it may be 20 or 25, okay? So what we need to do is determine which of those 25 actually, or 30, whatever the number is, needs to be a small number, actually affects paper machine performance. And that's in an ideal world. And what I mean by that is a lot of mills we see try to centerline everything. So you're centerlining nothing. So you really have to figure out what it is that's important to try to get this narrowed down. Calculate those targets and limits by product or by grade, as we call it. Ensure that these are used every single time, okay? That's what we really need to know. Okay, so here's the current state. There's a couple of process book displays that they can look. One's on their additive screen, and then one of them is a recipe tracking screen. If you've got 30 years experience, you're used to looking at it, you know what those numbers ought to be on that gray one. If you've been in it 2 years, you don't know if those numbers are good or not. They might be. So if we keep running this way, are we good? Don't know, right? The additives alarms at least let you know if you're in an alarm state and you have some targets on there, but what are the limits that I can actually run in? I know I'm not off target, but what are my limits? Am I still okay? So some of the first things we started to do was use limits. So I don't know if you guys all know this. I'm sure a lot of you do. Every PI attribute can have a set of limits associated with it. It's a matter of right-clicking, and there's a little thing called limits. They introduced this, I don't know, a couple years ago. Use them. And then what we did is we tied them to a table. And then that table, you can actually type the limits in if you so choose. You can link it to a spreadsheet if that's what you want to do, or if you have more advanced tools, link it to other databases. So that way you can pull those limits in and they're dynamic by grade. You change grades, the limits change with you, all your PI Vision displays change. So use that. Highly, highly valuable. Some of the other things that we had to do to make things look simple to the operator, we had to do some back-end work on calculations. So this calculation here is figuring out when did the grade start, when did the reel start, how are we running since we started the reel, how are we running since we started the grade. And so we're actually going to use that in a PI Vision display to kind of roll up some things to let the operator know, hey, how are you really doing? So this was the first thing we showed the mill, and I have some work next week when I get back they're giving me about 25 things that they want to put on a screen like this. So I'm not going to start on the top left. I'm going to start actually at the bottom. So I grayed out the KPI names there, but those would be, I just picked 5 that I knew that they were interested in. So the first boxes is just a value. And if it's green, you're within your specification limits. If it's red, you're outside of your specification limits. Actually, I'm sorry, I apologize. You're out of your control limits. We're not getting too sophisticated yet. Maybe between spec and control, we're probably going to turn that yellow. So it gives you like a warning indicator to say that you're out. Then the first column, since the reel started, you'll see 3 out of those 5 are green. So that's just the average of that value since I started the reel. Again, we're doing the analytic to figure out when we started the reel. And then we say, okay, has it been within limits since we started the reel? And that was 21 minutes ago in this particular case. That rolls up to the percent green for this reel is only 60%. 3 out of 5 are good. And then since the grade started 21.86 hours ago, everything's in compliance, so therefore you're 100% green on your grade. So very quickly the operator can look and say, how am I doing? It's a lot better than just a bunch of numbers. They still get the numbers, but they have a lot more context here. And we actually can use this in some of the other things that we're doing as well. We're also, and we're still trying to figure this out, I just put a little hyperlink for trend right there so we can drill into, and if they want to see how they've been doing, it will have the process variable along with all of the limits so they can see if they're staying on one side of the center line, when they violated things, etc. So we're going to make this very interactive for the operator. Now for the engineer, that's always the challenge. Give me all the data, but help me contextualize it. This is actually Power BI. They came out with this in December. This is something called Power KPI. And what this does is the spark lines over there, green, you're within your limits. Red, you're above your limits. Blue, you're below your limits. And then if you look on that bottom trend, you see a little gray line. It's kind of hard to see, but there's a little gray line that you can actually put your target there. So you can see how your target changes over the grades and actually see how you're doing over time. Put a couple filters in there for grade, crew, number of breaks. We're doing analytics to figure out how many breaks have we had or how much downtime have we had on a grade run. These can be used as filters. We have a date picker. And this was actually a screenshot using the PI Integrator or PI Integrator for Business Analytics. We actually just go hit refresh on the Power BI sheet and it changes the date context. Then we use the date picker. So for the engineers, this is a much more graphical view of what they've been able to do, and it's much quicker. A couple of other things that we started playing around with is on the top right, there's a hierarchical slicer. So what I did was each grade run has a series of reels in it. So we're using the multi-start trigger event frames. We put in the event path for all the reels of what grade it is we're running, which allows me to then use something. This just came out within the last couple of months in Power BI. It's on their marketplace. But I downloaded this hierarchical slicer. So in this particular case, the top is the grade run, and then all the indented events are the reels that were run on that grade run. You see all of them are checked but one. The reason that one's not checked was because I could tell by the data they were making a grade change. And when I show this live to people, the box and whisker plots on the left with the little green dots in them, they actually change. You can see the variability change very drastically because it's showing the max and min. So to me, very quickly, we can give the engineer some context around particular grade runs or go find success factors. It's very easy to say, oh, I want to export this data and look at it in some other tool. So this is a great way to contextualize the data. And then we give a roll-up of the percent green for the reel and for the grade as well. So really powerful stuff. Now, AF 2017 R2 allows us to rename the event frames. We can actually put the grade attribute and the reel attribute in the event frame name. So they'll be able to see it's grade X, reel 1, reel 2, reel 3, reel 4, reel 5. So they'll understand, hey, we had a problem on reel 7. They can go find that information very quickly. So again, it was funny. I completely redid how I was doing event frames once I saw the hierarchical slicer. So don't be afraid to go back and retool as new tools come out, okay? So moving on, you hope to never have a sheet break, but you do. How long does it take you to rethread it? So the business problem is the mill wants to understand, how long does this take? Okay? As you guys know, time is money. Sheet breaks are bad. Okay? That's lost production that you can never get back. Okay? So they want to know, by crew, by grade, how long does it take me to rethread? The engineer who wanted to solve this problem pulled lots of data in Excel, started messing around with Minitab, looked at it one time. This was his Six Sigma Green Belt project. Okay? Did this great analysis. Okay? Unfortunately, it wasn't really scalable because he was having to redo it. The worst thing is he transitioned to a new role. So now all that work's lost. So how do we make this scalable? Okay? So again, sometimes you have to do some complicated stuff on the back end to make something look really simple to the operator. So we did some analytics, and there's two different sets of analytics. You have real time. I want them to see how long each of the stages of the sheet break is taking in real time on a PI Vision display. But then I want them to be able to analyze over the course of a year or 2 years, or by grade, by crew, whatever, how things are performing. So we built sets of analytics for both cases. Then we were able to do something that looks fairly simple. Red bad, green good. So they gave us some targets. So I use those in the visuals. So, you'll have a break duration of 35 minutes. That's below their target of 45. Turns the box green. As you'll see, these numbers on the current or most recent break status don't necessarily line up. Okay, that may be okay. They gave me some logic that they definitively know each stage. That doesn't pick up the entire break sequence. What they're really concerned about is how long does it take to get through these different stages. As we get more sophisticated, we may change that up a little bit where we account for every single second on here. But right now, that was not a critical thing. Okay, so they get the last two breaks on those top two boxes, then they get month-to-date and year-to-date stats. So the one on the top left updates in real time. If they're in a break condition, they will see those numbers update in real time. And then once that break ends, the numbers on the bottom in the month-to-date and year-to-date update. So again, real-time, post-process analytics. And we did some back-end calculations for something very simple for the operators and the management to see how they're doing. From there, what we're doing now is we're actually rolling up all of these, and we've done some event frames with these to track some of these things. Then we built a view in the integrator and roll that up into Power BI. And as you'll see along the top, we have big honking numbers. Highly technical term, big honking, especially in the South. Big honking numbers. Anyway, so we have big numbers to draw attention. That's what was really important. All right, they click on that donut chart, and those numbers and those lines all change based on the crew. So that way they can see which crew is performing best, which one is performing worst. We've also done some similar things by grade. You see there's red lines on there for their target, so they can see the months they were above target, below target. So again, click on the crews. They can see which crews are doing well and where they're doing well. And what we hope is it's going to drive some innovation and some ways to get the sheet back on the reel much quicker. The other thing that was very interesting, these guys have a pro license for Power BI, so we can actually publish this to an internal web page. And the manager of manufacturing excellence told us, I'm going to put this in the control room because no crew wants to finish second. So you can drive performance by creating a little friendly competition between the crews. So we're actually going to be able to put this along with that PI Vision screen in a web environment in the control room. So really powerful stuff in my mind. So to sum up, our new workforce, we need newer tools, different, faster analysis. We need more context, red, yellow, greens. We need to build interactive displays in PI Vision, Power BI, Tableau, other tools. They should be simple. We should tell a story, okay? Draw the audience's eye to what you need them to see. If you guys notice, I'm bolding what I'm trying to draw your eyes to the points that I really want to make. My suspicion is that you guys are probably reading the stuff in bold before you read the stuff in gray. You may not even read the stuff in gray because that stuff in bold tells you enough. So I wanted to show you that and kind of think about that. You're trying to tell a story. You're trying to draw the person's eye to what it is you're trying to say. And trust me, the first things that I did was a kaleidoscope. It's colors everywhere, right? Jim, what are you trying to tell me? good grief. So I learned this. If you guys want to know a little bit about this, Storytelling with Data. Great book, Storytelling with Data. Excellent book. And actually, the lady that wrote it came out of the Google People Analytics space. So, and it's very applicable to everything we do. So anyway, we use the tools in PI, AF, Analytics, Event Frames to give us context. Use that PI Integrator for Business Analytics. Great tool to do large data pulls with. We started out with DataLink and PiloDB Enterprise because they were, each one got progressively better. But this one's even better and going to continue to get better, okay? Some design tips. Be cognizant of your audience. A lot of times you have 3 or 4 different customers. You have the operator. You have the operator supervisor. You have engineers. You have middle management. Okay? Be cognizant. Build tools that they understand, that tell them what they need to know in the level of detail that they need. Okay? We strategically use color, as you see. You probably saw that first on this display. That was probably where your eye was drawn because, hey, that looks really different. Okay? Be very strategic about your use of color. Okay? I've learned that from some other customers too who happen to be in the room. They're, a lot of the HMI companies, very grayscale, and then the color draws your eye to what it is. High performance graphics. Go look that up. I think it's very applicable to the world we live in. Do boxes and groupings around things. Okay? Use limits. Absolutely use limits. You can plug in the right tool to pull your limits from other databases, but start using them. Okay? Understand analytics best practices. These guys at OSI Soft have written a great document. A guy named Alish Sudek has spent a lot of time writing best practices. Go read it, practice it. One of the things that I didn't point out and didn't talk about in here, little things like on the variables inside the analysis, use a little letter V in front of all of your variables in your PI analyses, because then you may use them in some of your calculations. And you can tell if it starts with a little V, that's a variable. And if it's green and starts with a little, a single quote, you know that that's probably an attribute or a PI tag of some sort. So you can tell the difference. You have to understand the difference between periodic and event triggering, because you don't want to bomb your PI server. So read these best practices. I meant to put a link in here. I'm sorry I didn't do that. But you can Google it. My email's on here. If you want me to send it, I have it downloaded. One of the questions that Mariana asked me when she saw the first version of this presentation was, how do you know you're right? How do you know everything you're doing is right? You have to validate with your SMEs. I think the first presentation talked about this too. You have to work with the mills. You have to work with subject matter experts to validate what it is you're doing that is correct. Okay? So those are some of my design tips. There's our contact info. Okay? It'll be down, in the presentation that you can download. I'm going to take some questions and then I have a quick challenge for you.
Okay, we have a question right here.
So I couldn't help but notice that your control limits had a lot of significant digits. Are you using SPC to calculate that, or how are you calculating your control limits?
Right now, I picked some of the limits based on some things that I saw. The mills we're actually, first week of May, we're going to get the integrator built or installed for that mill. They're going to pull the limits and start calculating them themselves. I did that as proof of concept. Yeah. So sometimes we have to start somewhere. We have to show them why it's even important. Yeah.
We have a question here.
You mentioned the time in cheat break and tracking it and improvement, competition between teams and all of that. Mm-hmm. You didn't mention in grade changes. Did you see any improvement in the time it takes in grade changes, since you're giving the operators the better numbers to run by?
I don't think we've gotten that far yet. I don't think we've gotten that far yet. I mean, this is going to spiderweb from here. These are still fairly new concepts that have not been playing in the mills for a long time yet. So I wish I had a better answer for you. Well, great question.
And the other side of it is the mill engaged Jim to look at the recovery time problem. That was what they identified as their most important problem right now. And the hardest part of transitioning people from older thinking to newer thinking is you've got to be able to show them something. And you really want to show them something that solves a problem that they feel, so they start using it. And then they start asking you for all these other questions.
Hi, I'm Chi from Chevron. So I'm a newbie for end user. And so I'd like to know what it takes to build a basic analytic tool that you just showed. So I have basic knowledge, very minimal knowledge with the Pi Explorer and the Vision. So I'd like to have to monitor the, like for a batch, I have step 1 to 10. So I'd like to build a analytic tool every day or maybe once every month. And when I pull it up, it tells me step 1 to 10, which batch is outside the golden step. So when I click on that, it would lead me to batch start in which day, and then I wanted to run through the logic and say, this step, does it charge the right quantity of raw material? If yes, then what it does, and then it will give me the potential issue of that step, what caused that, so that I can go in and do the troubleshoot. So I'm doing it manually now. It's very labor intensive. Then we'll have to pull the data again and again.
Yep. You want to start this one?
I'll start. So the key points you said is I'm doing it manually now. So one of the hardest things is knowing, do I have the data and do I believe the data? So you at least believe the data for what you're doing now. I think I can still safely say I've never taken a Pi training course. And so all of this stuff is either through Pi Square and the videos and just trying it. It is really that simple. I mean, there are lots of great examples out there, but you have to start kind of like Jim did when we're going. You don't want to try to swallow this huge project all at once. Get a little piece of it working, and maybe it's to Excel to solve that part of it. I can do some filtering there. Okay, now when I go look over at the integrator or I look over at the BI tools, have them feed from my Excel spreadsheet first. And so I've broken it up into little pieces, and then I can do the whole thing all together.
Yeah, and my comment is, how long does it take? Well, it kind of depends on what you try to do. The stuff that I've showed you in just pure effort, 2 to 4 weeks max.
From zero.
From zero, right? But a lot of times you can build stuff in a few days. I mean, there's a few little tricks and nuances you have to learn about AF analytics and how the data comes into you. But once you do that, I mean, start something very simple, you know, and then you can build on it. You know, that way you're rewarding yourself by solving some little problems along the way. Do it incrementally. Don't try to solve everything. So, but okay.
Yes. On a couple of your Pi Vision display examples, you had what looked like a display value visualization that had some multi-state and was tied in with an arrow and a target and a percent of target. Yeah, there you go. I'm wondering if that is a single built-in visualization, or is that something you had to custom build?
It is absolutely out of the box. So that is a value. It is just like all the values up top. If you right-click on it, it'll give you a series of options, and you can show, you know, if you want to show targets and things like that. I stumbled on it, actually.
So you need to have that targeting and limitation built into your attribute structure to bring that up.
That is correct. All the multi-states inside of Pi Vision are driven off of AF traits. That's why I'm preaching, use them, because then they become incredibly valuable. I've done it for phases too. We can actually do it off enumeration sets on phases of batch digesters as well. There's all kinds of little creative things that you can do.
So you have Pi Vision here, and then you used you had Pi Vision here, and then you had the BI tool afterwards. This one here. Why not just do it all in Pi Vision? Why then send it into BI? How did you make those decisions?
So Pi Vision's great at looking at stuff in real time. It was not as good of a tool at looking at a long swath of things and slicing through the data. And one of the issues here, and I'm still fighting this, is the year-to-date, month-to-date stats. I have to filter out the planned down days or annual outages. So I'm still working through how do I do that in Pi Analytics. With this, I can say I want all of the break durations over 400 minutes and all the wet end wash-up times over 200 minutes out of the equation, and boom, they go away, and I have some real numbers to work with. So it's much, much easier to filter out some of that stuff in the BI tools, and it's a lot harder to do it on the Pi side. So use the right tool. You need a whole toolbox, right? Not everything requires a hammer. Sometimes you need a screwdriver.
And on the other side too, BI would be a lot of work to get it up to the BI tools to show you the real-time stuff.
Yeah, and the weakness in Power BI, Tableau not so much, Power BI is I can only roll up by the day. I can't go down to minute, second. Tableau, you can go all the way down to the second, but you have a much higher cost of using that tool. Okay, so here I wanted a daily roll-up. So again, you're trying to use the right tool for the right thing, and this is very performant, with that level of data.
This is Raj Jakete. Have you talked a little bit about the digester and some of the analytics you've done with that. With this is awesome. Have you done something similar on the paper machine side, where you're looking at the defects with a Cognax or some sort of imaging system, and doing the analytics really to run the paper machines more optimally?
So I have another potential customer that we're actually looking at that. We're looking to try to figure out why they're having so many halo spots. I think, and I've showed them these kinds of tools, like, hey, I think we can use that, but I think we may get into machine learning as well. And unfortunately, they had some other projects come up, but I think that's going to come back around. I think these kinds of tools, and I think you're going to need some machine learning and some other tools to be able to solve machine defects and use the Cognex data. I see that as an opportunity, though. Because what you might see, like in their case, they'd see this big influx of them, and they couldn't understand why, right? And you can build event frames around that and build context, look back in time. So I think these tools will be tremendous for that, but if that's the big problem, right?
So you have all these great tools. How do you get your engineers? My biggest problem is getting my engineers engaged with, I've done your event frames, I've done your visualizations, here's your data. Now use it.
I was hoping you were going to be able to tell me that. I actually have the same problem, and we talked about this. Everyone's in firefighting mode, but nobody wants to put down the hose. And I preach. There's some people in this room that will tell you, I preach to them. If you'll put down the hose for just a little while, I can make it where that fire doesn't start or it doesn't get as bad. And they're like, we don't have time to put down the hose. So I don't know the answer to that question. That's why I'm kind of preaching and why I'm a little passionate about this, because we can save you time with this stuff.
Yeah, I was talking to one of my digester SMEs a couple of weeks ago, and I said, give me 5 hours. I can save you 20. He says, I don't have the time. So what are we doing? I mean, in our vision, we're going to kind of force this. We have a lot of young engineers that are coming in. So I am trying, I think read in the introduction that I do a lot with training of the young engineers. I am brainwashing my young engineers. Now, I don't get all of them, okay? But all I need is a few. And one of the things that we're doing this year is putting development servers out at each of the facilities. And we're showing them, because some of these tools are great for ad hoc project identification. You can do stuff in AF and in the analytics that to try to capture data, export it to Excel, and then do something is really hard. If I get them hooked on how to do that for themselves, even if it's throwaway, they start seeing the image. And we tell them, if you build something good, then work with IT, we will move it to production to make it permanent. Now, we may change it some to try to IT-ize it, but if it was good for you to solve problems, and we can take 5 or 10% of that and make it permanent for good stuff, that's how we're going to try to do it. Now, we're in the year of deploying that right now, and I'm still in the years of brainwashing, but that is the method we're going to go after. Because trying to find your 20-year, 35-year person and say, give me 2 days, they'll say, okay, let's do it in the first week of December of 19, and when you get there, they're busy. So I feel your pain.
Yeah, it actually, people have asked me, you know, what's your biggest challenge in growing your business? What you highlighted. You know, it's like, I can help you. And I had one of my customers now, I was asking for some of his time, and he said, I don't have time, because he was fighting fires. Of course, I knew him pretty well. I sent him, you guys probably all seen this, the cartoon of the cavemen pushing the square wheel wheelbarrow, and the guy standing behind him has a round one. I just sent that to him, right? I didn't say anything. It was just the picture. And he's like, yeah, the problem is you need to come alongside us and help push the wheelbarrow while we're putting that on. I can do that, right? We just have to keep pushing the message, I think. I wish I had the golden answer. Danica.
Only thing I might add on that, thank you. Only thing that I might add on that is that at a recent implementation we've been working through, we had a lot of training sessions on using the event frames and, you know, different things that you could be looking at. And the first couple training sessions, there weren't a lot of people there. And then the plant manager sent out an email saying that I will expect you guys to know how to use this, and this is a part of your job. And all of a sudden, we had 40 plant personnel at our last training session. So many of whom are using it and asking these questions. So there is so much to be said for having things come down from above in terms of using new tools.
That is really important. You have to get management on board, and in their case, their plant manager was absolutely on board.
Hi, Bob Coate. I actually work in renewable energy, but
Okay.
I work in data science. So I was kind of curious about, I mean, you mentioned or said in the description about Tableau and Power BI. I've personally tried to use both, and one of the issues I have is, especially with Power BI, I know you said you're going to do it in a different talk, but my general question is, like, right now I automate a pull from our PI data into a large CSV, push that into Power BI, and then actually automate the refresh of Power BI through batch scripts and all that. Do you know off the top of your head, is there a more efficient way? I mean, we have large millions of pieces of data we're pushing in, so I'm just curious.
I think you need to look at the PI Integrator for analytics or data warehouse. You know, get with your account manager on that, because that's really kind of what it does behind the scenes. And I think that's going to be a way that we all don't have to work so hard on that. 3 years ago, that may have been your only answer for what you're doing. But I think explore that, you know, go talk to them at the booth and see if that would work for you. And it's not that expensive to get started in it.
All right. Thank you, sir.
Yeah.
Okay, so we are right on time, and I want to thank you, Jim and Rick, for the wonderful presentation, and please help me thank them with an applause.